Grief. Most people think they understand it. 5 stages: denial, anger, bargaining, depression, acceptance. A clean ladder you climb until you reach the top and feel better. That's not what grief is. That's not even close to what grief does to a brain. Grief is a neurological event, a biological disruption. It rewires your brain's architecture, alters your hormone levels, and physically changes how you perceive time, pain, and reality itself. The stages aren't a staircase, they're weather. They come in any order, sometimes all at once, sometimes not at all. What actually happens inside your brain during loss is stranger, darker, and more fascinating than any 5-step model suggests. Level 1. Denial. The brain doesn't accept death the way it accepts other information. When you learn someone is gone, the prefrontal cortex, the region responsible for logic and rational thinking, receives the news. It understands it. But the deeper limbic system, the part that holds emotional memory and attachment, doesn't update right away. It keeps running its old programming. It still expects that person to exist. This is why the first phase of grief feels so disorienting. It's not weakness, it's a lag in the system. 2 parts of your brain are running different versions of reality at the same time. One knows they're gone, the other keeps reaching for them. That reaching has a biological root. The brain stores the people we love as neural patterns, networks of expectation, habit, and prediction. When you live closely with someone, your brain builds a living model of them, where they sit, how they sound, when they'll call. Grief begins the moment that model loses its source, and the brain, stubborn and efficient, doesn't dissolve those patterns overnight. They persist, they keep firing, and every time they fire against an empty space, that's denial. That's the brain still trying to locate someone who is no longer there to be found. Level 2. Shock. Even before denial fully forms, the body responds. Cortisol and adrenaline flood the system, the same stress hormones released during physical danger. Your heart races, digestion slows, muscles tighten. The body treats grief like a threat because to the nervous system, it is one. This chemical surge creates the numb, dissociated quality of the first hours and days after loss. You function, you make calls, you answer questions, you handle logistics, but it doesn't feel like you. That's not strength. That's your body narrowing its bandwidth to survive overwhelming input. Sustained cortisol also begins to suppress immune function. People who are grieving get sick more easily. Inflammation rises, sleep fractures. Grief isn't just emotional. It carries a measurable physical cost from the very first moment. Level 3. Searching. Researchers have observed a behavior in both grieving humans and animals called searching. It's automatic, unconscious. You catch yourself driving past places you went together, reaching for your phone to text them something before remembering, glancing at their empty chair, scanning crowds for their face. The anterior cingulate cortex, which monitors discrepancies between expectation and reality, keeps flagging the absence. It can't stop. It was built to find, and it keeps searching because the neural model of that person is still running, still predicting their presence, still waiting to be confirmed. This is why grief feels so physically exhausting. It's not only the sadness, it's the constant low-level cognitive effort of a brain trying to locate something it will never find. A search that never resolves. A door that keeps opening onto the wrong room. Level 4. Anger. Anger and grief isn't irrational, it's neurological. When searching fails, when the anterior cingulate cortex repeatedly registers that something expected is missing, the amygdala activates, the brain's threat detection center. It responds to loss the same way it responds to danger, with alarm, urgency, and aggression. That's where grief's anger comes from. It isn't misplaced. The brain has registered a real wound, and the amygdala is responding the only way it knows how. The anger might land on a doctor, on God, on circumstance, or even the person who died. It doesn't matter where it lands. It comes from the same place, an alarm that can't find anything to fix. Anger also gives the brain something raw. Grief doesn't. A sense of agency. Sadness is passive. Anger moves. And a brain in distress will often choose movement over stillness, even if that movement leads nowhere. Level 5. Pain. Grief activates the exact same neural regions as physical pain. The anterior insula and anterior cingulate cortex, the structures that process the feeling of being hurt, light up during acute grief in the same pattern as they do during a broken bone. This is not metaphor. When people say grief hurts, they mean it literally. The brain experiences it as damage. This is why loss can cause real physical symptoms: chest tightness, shallow breathing, a heaviness that lives in the body. The brain doesn't distinguish between a broken bone and a broken attachment. Both register as injury. And like physical pain, grief creates hypervigilance. Reminders, a song, a smell, a certain light, trigger sudden, overwhelming grief bursts. The world becomes full of nerve endings. Level 6. Bargaining. Bargaining is the brain desperately trying to restore control. The prefrontal cortex, responsible for planning and problem solving, starts running hypotheticals. If only, what if, maybe if I had. It constructs alternate timelines, searching for the variable it could have changed. This isn't delusion, it's the brain's problem-solving machinery being deployed against a problem with no solution. The prefrontal cortex is built to find leverage, the point where action creates change. Grief offers no such point, yet it keeps looking anyway. Sometimes this bargaining turns into negotiation with something larger: fate, God, the universe. If I do this, will you undo that? It's the brain asserting agency in a situation that offered none. Level 7. Depression. Weeks in, the cortisol takes a different toll. Dopamine levels drop. Serotonin becomes dysregulated. The brain's reward circuitry, the system that creates motivation, pleasure, and the sense that life is worth doing, goes quiet. This is grief's depressive phase, and it is not weakness. It is neurochemistry. The brain has been running in crisis mode. The same stress hormones that mobilize the body now suppress joy and forward motion. The world goes flat. Color drains away. Getting out of bed feels impossible, not because you're failing, but because the chemical architecture of motivation has been depleted. This is often when people feel most alone. The acute crisis has passed. Others have returned to their lives, but the brain is now in its slowest, most depleted state. The grief feels heavier than it did at the beginning. That's not regression, it's biology. Level 8. Reorganization. The brain is plastic. It changes in response to experience, and its deepest drive is to restore equilibrium. Slowly, this is what happens in grief's later phases. Not acceptance as a final destination, but reorganization as a process. The neural model of the person doesn't disappear. It transforms. What was an active prediction, "they will be here," becomes a memory. The search behavior quiets, not because the love ends, but because the brain has updated its map of the world. This process takes far longer than our culture admits, 1 to 2 years for significant neurological reorganization, sometimes longer. The idea that grief should resolve in weeks isn't based on science. It's based on how long other people can tolerate your sadness. What remains grief doesn't end. It integrates. The brain incorporates the loss into its structure, the same way it incorporates any experience that permanently changed it. The person becomes part of how you see the world, a reference point, a lens, a quiet presence that shapes you even in their absence. What looks like acceptance from the outside is, neurologically, a reorganized brain living in a new internal landscape. The pain doesn't vanish. It changes form, from an acute injury into something you can carry without breaking. The brain learned to love someone. That learning doesn't reverse. It simply learns to carry a different weight. And one day, the caring stops feeling like carrying. It starts to feel like part of who you are. Something you grew around. Something, quietly, that made you more.